Hello students, right now we are getting to do the second exercise of chapter 5, which is more advanced and more complicated in terms of solving for time value money problems. And right here our exercise consists of different questions, and I'd rather to start with question number 2 because this is relatively easier and also more consistent with the example in the PowerPoint. So here you are financing a home mortgage. Well, congratulations, you are just getting a new house. The thing is, you also are carrying debt, and the mortgage is calculated based on the money you borrow from a bank. And right here is a screenshot I got from Zillow.com, and I was looking at a house in Orland Park. The price of the house is $399,808. Okay, so that's a pretty normal price for that area, and the percentage for down payment is 30%. Okay, so I'm going to put $119,000 as a down payment. That also means I'm going to finance the rest 70%. I'm going to borrow from a bank, either Bank of America or Chase or Wells Fargo. Alright, so I'm going to finance the rest of 70%. That's going to be my mortgage. And also I'm in a program of a 15-year mortgage with a fixed rate of 3.138%. So that's my annual rate for interest, and it's going to last 15 years for the mortgage. My credit score is 760 or above, and basically that's a good credit score. If you are a homeless person, then your credit score probably will be 200 or less. Right here, all you need to do is to verify the principal and interest of 1951. Okay, I want you guys to calculate your principal and interest or the monthly payment and get this number done. So how exactly do you need to do it? So once again, you get to the apps and finance time value money solver. Alright, so that's the setting you have here, and remember, your mortgage payment is made on a monthly basis, so you have to do a lot of adjustments here for the factors when you input in the numbers. For example, you have 15 years to pay the mortgage, right? The thing is, you are paying it on a monthly basis, so you need to multiply 15 by 12 to get the number of months, which is 180. And for the interest, it is the 3.138 you put in there. The thing is, you should have a monthly rate instead of an annual rate on your calculator. So the annual rate will be divided by 12 to get the monthly rate. Alright? And for the present value, how much are you borrowing? Are you borrowing the full price, or are you borrowing part of it? The answer is you already put 30% down, so you just need to borrow the rest of 70%. And you can use 399,808, the full price, multiplied by 1 minus 0.3, which is 30% of your down payment. Okay? And then Excel will automatically calculate for you. So you are only borrowing this amount of money from the bank based on which you pay monthly mortgage payment. And then you solve for payment, put it 0, and we will get back there to solve. For future value, there's no additional amount of money you pay after 15 years, so just to put 0. So you only pay monthly mortgage. You do not pay any lump sum money in addition to that. So you get back to payment, make sure this is highlighted, and I want you guys to hit alpha, enter. So that's how you solve it. And you will see my monthly payment is a negative 1,951. So that's how much I pay. It's negative because today I borrow this much money, $280,000 like that, and then I need to pay later. So that's going to be a cash outflow later for the payment. This is a method offered by your textbook because your textbook really does not have this PY or CY playing a role there. So your textbook only give you 1, 2, 3, 4, 5 factors plus a payment method. How do we utilize PY and CY? So if you wanna follow the guidebook of your calculator, you just need to move back to the interest and just to put the annual interest there, 3.138, and don't just divide it by 12. Instead, you move it down. You define number of periods as 12 in a year instead of 1 in a year. And then you will get back to payment. So let me just make it 0. And I try to solve. So the difference I make here is instead of putting monthly rate, I put annual rate. And instead of using 1 for PY and CY, I use 12. Okay, PY and CY stands for number of periods and a cash in a year. And then I do alpha, solve. So I got the same answer. So basically I just taught you 2 methods to get the payment, and these 2 methods applies when you do not have annual payment. Instead you have a monthly payment or even quarterly payment. Okay, so that's for question number 2. And then let's move to question number 1. A car dealer offers 0% financing for 3 years or a $2,000 rebate on a car which is selling for $29,000. So it's an either or situation. Basically, it's asking you, it's giving you 2 options. Option 1, that's 0% financing. That's pretty good. You don't pay interest. And option 2 is a rebate. And a rebate basically means an instant markup of the price. So if they give you a $2,000 rebate, so you buy the car, you pay the full price of $29,000, and then tomorrow they're gonna mail you a check of $2,000. So effectively, you are paying $27,000 for the car. So that's a $29,000 minus $2,000. All right, and you want to know which option is better, and the better option will require smaller monthly payment. So your story here is, no matter what happens, what option you choose, you will drive a car home. You will drive the same car selling for $29,000 price. You will drive that car home, and then you will pay a monthly payment, okay, for that car loan. And the payment will last for 3 years, and it's either through the 0% financing or a loan with a 36 months, which is also 3 years. All right. So basically, you need to calculate the monthly payment 2 times. Okay, one for option 1 and one for option 2. All right. So now let me just get to my calculator. All right. So I'm going to put a 36 for number of months. I do not put 3. I do not put 3 years because the payment is made on a monthly basis. All right. And for 0% financing, I just put 0 there. And then the present value is $29,000. It is true that you pay $29,000 to the car dealer. It is also true that you are getting $29,000 from a credit card company or from a bank or from the dealership financial department. Does that make sense? So within that financial relationship, you are getting $29,000 positive into your pocket so you can buy the car. For that money you borrowed, you will pay a monthly payment each month in the next 36 months. All right? So you try to get the payment, and we're going to solve for it. Just put a 0 for future value. It's 0. So there's no additional money in addition to monthly payments. Okay, and for present value, for PY and CY, make them equal to 1. Okay, if it's 12, it does not matter because it's 0 up here. Okay, or you can just move it up, make it a 0 divided by 12, which is also 0. So if you use a monthly rate for the interest, just divide that by whatever rate by 12. Here it does not make a difference. Okay, and then you move down to payment and then hit alpha, enter. So your payment is negative 506. Okay, it's negative 806. Now let's look at the second option. The second option better. Does that require a smaller payment? We will see. For the second option, the number of months is still the same. All right, so still the same. It's a 36 month, and the interest is actually 6%. Okay, it's 6%. So you put a 6, and you're gonna divide 6 by 12 to get the monthly rate. And the present value, well, it's true that you're gonna pay for the car, but effectively you're only paying $27,000, and you are borrowing that $20,000 for a loan. So you're gonna put $27,000. So that's how much you are financing, right? You borrow $27,000. You don't have to borrow $29,000. Okay, and then the rest will be the same. Then you just solve for payment alpha, enter. So it's going to be negative 821. All right, and to finish this calculation, you can also put the payment as 0, and so what I'm trying to say is put PY and CY equals to 12, and for the interest it is 6%. Just leave it as it is at the annual term. Okay, and then you scroll down to solve for payment alpha, enter. So you get the same result, 821. So I just to show you how to get the payment using two different methods. One method follows the textbook, which does not have a row for PY or CY, and another method basically follow the textbook, follow the calculator guidance, which you have a number for PY and CY. So which one is better? Of course, option 1 is better, right? Because it requires smaller amount of payment. So you just walk home, drive a car home, a new car. Just option 1 requires you to pay smaller amount of money. Okay, so question 3. You are financing a credit card, and that credit card charges you 24% each year, but it's compounded monthly. And you are financing $8,000 credit card bill by paying $125 each month. How long will it take to pay off the bill? All right. So what is asking you to solve for n? Of course, the thing is you are financing an $8,000 credit card. So is that positive 8,000 or negative 8,000? That's question number 1. It should be positive, okay? Because you are borrowing $8,000 from a credit card company, and then you will pay it back through monthly payment. You may use the $8,000 to buy a second-hand car or buy a PlayStation with 300 games. It does not matter however you spend the money. What matters is you just borrowed $8,000 from a credit card company, and when you borrow it, you receive the money, you receive the cash, so it should be positive. So if I put the number in to my calculator, so I leave 0 for n, and the interest rate is 24, and it's a monthly rate. I'm going to divide it by 12, okay, and I'm going to make PY and the CY equal to 1, okay. Just follow the textbook method. You can also use the alternative method, does not matter. And for the present value, as I mentioned earlier, is 8,000. 8,000. Okay, so I'm borrowing $8,000 from a credit card company to do some crazy things. And then I move down, and I'm going to pay $125. So that's going to be negative. All right, I'm going to pay that money. So after everything is set up with 0 future value, I move all the way up to solve for n, and I will get an arrow. Okay, I will get an arrow. So if I do alpha, enter, so that's an arrow. So what's happening? Why did I get arrow? Did that mean I put the numbers wrong? Okay, so if you hit, just to get back to that app, the thing is when you have a 24% annual rate, okay, 24% annual rate, it's like you are getting 2% per month, right? So 24% each year is 2% per month, and 2% multiplied by $8,000 is $160 just for the interest. So how much are you paying? $125, and the money you pay just cannot cover interest rate alone, not even mentioning the principal. In other words, you can never ever pay back this $8,000 credit card bill with that payment. Does that make sense? That's why your calculator gives you an error page. All right. So so that's one way to show my point. That's actually what's happening in America right now. So each American household, on average, has a credit card bill of $16,800. Okay, so that's a lot of money for each American family, and on average, the credit card company charges to 20% interest. So each year, one American family needs to pay around $3,000 just to pay off the interest of a credit card bills. All right, think about that. So that's quite some consumption there, and you could easily get enslaved by the credit card bill because you just keep paying it, and your payment would just barely meet the interest, and you cannot really pay back the principal in any time soon. So the enslavement by credit card is really a financial trap that each of you should avoid. All right. So for practice purpose, I want to change this 24% annual rate to 12% annual rate, and then we will see a valid answer. So what happens here is I'm going to use a 12 annual rate divided by 12 month, so that's 1% each month, and then I solve for the n, alpha, enter, and then my n is 103 months. Okay, 103 months divided by 12, so that's roughly 8 or 9 years. Okay, so that's how long it's gonna take to pay off the bill with a 12% interest rate.